Um, one second. Okay. Start with first question says 2x squared minus x minus 3 all over 2x cubed minus 3x squared plus 2x minus 3. So this simplification basically just simplify the top. So I'm going to do the top 2x squared. You still don't know how to do by box. I'm telling you, box for you guys is probably the only way to go. Only maybe 2 or 3 of you guys can really factor very well. You don't need to use a box, but I won't take that risk. Even my calculus kids, I switch them. So I think 1, 3, 2x, 3x, and this one, this is negative. So it should be 2x minus 3 times x plus 1. Did I do okay? Okay. Do you guys did okay? Yes? Katie, do you know how to use a box now? Did you do it right? Okay. So now factor by grouping is basically this 4 term. Anything 4 term, you're gonna have this parenthesis right there. Now I assigned that parenthesis before the addition sign. That's not mathematically correct, but that's gonna help you in some way to organize things, because sometimes you have to factor out -1, sometimes you have to factor out +1. Even though that plus sign that is there, that this is not mathematically correct right there, but I just choose to do that because a lot of things gonna come out easier to see. What can you factor on the first 2 terms? X squared. So that's gonna give you this, right? So that's gonna give you 2x minus 3. Sorry, that's gonna be blue. I cannot do that. Okay. Let me just erase this. So let me do that again. Just have a color code that way you can see it. So that's gonna give you a 2x. No, sorry, x squared and 1. I can factor out 1 here. And I'm going to go here. What do I have left? 2x minus 3 and the 2x minus 3. Hopefully you see that. Now what happened at the bottom? I can factor out a 2x minus 3. And what do you have left? Yeah, x squared plus 1. So it'd be 2x minus 3 times x plus 1. So now this is a cancel. That's going to be x plus 1 over x squared plus 1. Now anything else can cancel here. Huh?
The one.
No, they cannot cancel. Safa? No, because you factor out negative, then there will be negative x squared, -1. That's not a really difference of square. So nothing can simplify from here. That's it. Yes.
Can you expand the one on the bottom says x plus 1, x plus 1?
No, you break the math right there. Think about it. If you have x plus 1, this is actually called, this is bad, so, but that's okay. This is called perfect square trinomial. That's equal to x squared plus x plus x plus 1. That's equal to x squared plus 2x plus 1. So therefore, this does not equal to that. So no, this is not a good path because you cannot factor, you can only factor difference of a square, not not sum of the square. Sum of the square is called prime. It's not factorable. Later on, I'm going to teach you how to factor it, but right now it's not factorable. Yes. It doesn't matter. You have to be a minus sign right in between. Okay, yes. No, you cannot. So the thing is like the thing that you can simplify only if it's a factor. So if you think about it, this one's going to be x plus 1. This one's x times x plus 1. This x is not a factor. Now, if you have, says, I don't know, if you have like something like this, so for example, the way I kind of give analogy is really like this. So let's say 2 over 2 plus 4. That 2 cannot simplify. Okay, that 2 cannot simplify. However, if I make some adjustment, you can simplify. You know the answer is 2 over 6. You know this is 1 over 3. This is the correct path. The final answer should be 1 over 3. But how do you get 1 over 3 to deal with this? The correct way to think about it is 2 factor out 1 plus 2. Now this 2 is a factor compared to the, this 2 is not a factor. Does that make sense? So this 2 can simplify it down to 1. So it'll be 1 over 3. This is the correct way to do it. You cannot cancel that 2 with no reason. You cannot cancel 1 for no reason. X squared plus 1 does not make a difference of a square. That's called sum of the square. That's called prime. That's not factorable. Are you okay? Okay, so even through a small question like this, there's a lot of misunderstanding still. And we need to fix every single part of that before the next test. So, second question. Ax squared over 3x squared minus 12 divided by 40 over 2 minus x. There's a trap here. But I don't know if you guys see it. The problem is this is not in descending order. And I don't like that's not in descending order. But you can actually factor out a something to become a descending order. Okay? First thing. How many of you guys are confident with this question? Only 5 of you guys, and that's bad. Okay, so I'm going to take out a 3 here, GCF. When you're factoring, always take out GCF. Did you do that? Okay. Divide, so I'm going to change it to times. Not only that, I'm going to take out, this is not in the correct order. This is negative x plus 2. You can factor out a negative 1. So it'll be negative 1 of x minus 2. Is that okay? And this is a 40. And there's a difference of square. If you see that, that's not x squared plus 4 is not factorable. X squared minus 4 is factorable. So it'll be ax squared over 3 times x plus 2, x minus 2, times by negative 1 x minus 2 over 40. Now, can anything simplify here? X minus 2, that's a factor, right? Double check is a factor. That means that thing times the other thing, not adding to the other thing. Let's say 1 plus x minus 2, that cannot cancel the x minus 2. Now, you have to make sure that's multiplication. See that negative 1 times x minus 2? See that x plus 2 times x minus 2? That is that. Okay, so anything else can simplify? Yes. Omar? Can you divide by 8 on top and bottom? Yes. So that is going to be 8. And that's going to be 5, right? So that's going to be negative 1 x squared on the top. On the bottom, it's going to be 15 times x plus 2. Can that x and x cancel? No, because that's not a factor. This should be a final answer. Questions? How many got it right? 1, 2. Group leader. Okay, non-group. Ooh, that group's really good. Ashton. Okay, Ashton should be group leader. Safa, Austin. Who else? Charlotte, did you get it right? Do you know where you got it wrong, Charlotte? Where?
Instead of taking out like a common,
Where's... Oh, you multiply across. Oh yeah, you have to factor everything. Look for simplification always. Okay, so good. That's fine. You at least recognize a mistake, and that's fine. All right, 3. Now you don't need a common denominator when you multiply. A lot of people thought you need a common denominator. You don't. Common denominator only for addition and subtraction. Okay, so the next question is 2x plus 3 over 3x squared minus 5x minus 2 minus 6 over 6x squared minus 13x minus 5. So okay, Katie, do you factor 3x squared?
I got 3x plus 1 over x minus
3x plus 1, so that's C. 2 and 1. 3x plus 1. Oh yeah, that's good. That's good, that's good. So 2x plus 3 over 3x plus 1 and the x minus 2. Good job. Okay. I still don't know how to pronounce your name. Merle.
Oh, really?
Yeah, did you factor the 6x squared minus 13x?
No, I just got to the first one.
Okay, did you get it right on first one?
Yeah, I got it.
Okay, so we're gonna do it together. 6x squared minus 5 and negative 13x. What need to be the first row? Where's first column?
2 and 3.
Okay, let's try 2 and 3. I don't know if it'll work. And then the second one's gonna be 5 and 1, right?
That's my
So 5 and 1 is gonna be here. So that's 15x, and that's gonna be 2x. Which one need to be negative?
um,
The 5. Good. That's good. So it'll be 3x plus 1 times 2x minus 5. Hopefully you guys have got all this thing. Now let's determine what's LCD here. LCD is going to be 3x plus 1. That's what they usually have in common. So this is a common. And this is difference. Difference is here. And this is a difference. So there's a common here and there's a difference here. So that means I'm missing something on the first one. What do I miss? 2x minus 5?
Mhm.
But can you make sure multiply top and bottom? And what do I need on this one? Good. Now, I will say most of people will get down to here, no problem. But the biggest problem is right here. This is negative 6. The negative 6 is going to distribute to all the term behind it. So don't make mistake there. So that's going to give you a 4x squared. Now, this is just times. This is binomial times binomial. And plus 6x, right? I think. Minus 10x minus 15. I usually make a lot of mistakes. Just make sure I don't make mistake. This negative 6 is going to distribute to x. So it'd be negative 6x and plus 12 rather than negative 12 over the LCD. So now just combine like term. 4x squared. The 6x and the 6x here cancel out. And that's going to be minus 10x minus 3 over the 3x plus 1 times x minus 2 times 2x minus 5. Does that make sense? Anybody got this one right? So group leader. Okay, this one. So how did you get it right? Which one? The second part? The negative 6?
Multiplied by 3x plus 1.
Okay, all right, good job. Yes, have a question? No? Okay, good. Okay, so, yes, Brendan? Probably can, but it's not going anywhere. But oh, that's a prime. That's not factorable. You can try it. It's not factorable, I think. Wait. I don't think you can, right? No, 4, 2, 2, 3. That's 8. That's not factorable. All right. So far, is that okay? Let's just review. This could be a 3-question test right here. But except your test is not 3 question. Your test is gonna be a lot. So you're gonna have to adjust the speed, and you gotta it's 2-page front and back. But yeah, you gotta go through all this thing. You have to understand like nobody can. Now let's go through complex fraction. What is complex fraction? We did a first thing. We did a complex fraction before. So for example, this is a complex fraction. This is a complex fraction. This is a fraction within a fraction. So that's called complex fraction. And this one's fairly easy. Hold on a second. This is 9 on the bottom. That's a really bad handwriting. This is 9. So to do this one is actually super easy. Just recognize that this is this fraction divided by this fraction, right? But there's a parenthesis here, but this, yeah, you can simplify if you want. But I'm just gonna do 2x 27y squared. I'm gonna do dividing by 6x squared over 9. Is that okay? Did I do anything crazy? No. 2x 27y squared times 9 over 6x squared. Now I can see anything I can simplify. The 9 and 27 times by y squared, they are a factor. So that is going to give you the cancel. This is going to give you cancel. That is going to be 3. And this is going to be 3 as well. So that bottom is going to be 3x squared y squared. On the top, it's just x. Now x and x can cancel out. That's that's gonna be 1 over 3x y squared, and that will be the simple simple answers. Yes.
You do 3 times 3 making it x squared y squared.
Oh yeah, on the bottom. You're right. Very good job. This is 9. Is that okay? Okay. Yeah, I did forgot to 3 by 3.
I still got the right answer, but I factored out the two, like the x from the 2x first before.
That's fine. As long as you get the right answer, I don't really care which way you do it. As long as you get there. Okay, so now I'm gonna show you different questions though. Let me ask you this question. So x over y squared plus 1 over y. Oh, sorry, sorry, my bad. 1 over y over y over x squared plus 1 over x. Now, what this problem doesn't show is most of people want to do keep change flip there, but it's not. What this problem doesn't show is there is an invisible parenthesis where? On the top bottom. Yeah, so we did that with a number before. We did that with a complex number minus complex number. We told you there was a fractions there before. So that makes what we have to do first. Common denominator of what? The top, yeah, of top and the bottom, right? So this one, what is common denominator between y squared and y? So what am I missing? So am I just missing y here? Is that okay? What am I missing on the bottom? X over x. Now, if you realize this is not a different problem than the number. This is just going to be y squared on the bottom, and this is x plus y. Is that okay? And this is the x squared, and this is y plus x. Is that okay? Is that good? Did I do anything crazy that, like, you feel like I break math? Now, this divided by this. Well, guess what? X plus y over y squared divided by y plus x over x squared. Now, can this change order? Associate property says, I don't know, it's commutative or associate. I always get confused which property is which. I'm like the worst math teacher you can find that doesn't know the difference between associate and commutative. Huh? I never care. But I remember, like, I teach my son pre-algebra. Daddy, how come you don't know what's the difference between commutative property and associative property? I don't give a shit. I just know 2 plus 3 equal to 3 plus 2. Okay, so x plus y over y squared, and I can change that to times x squared over x plus y. Why? Because x plus y plus x is the same. And that's a factor now because this is a factor there times by 1. So I can actually simplify this. And that's equal to x squared y squared. And that's it. That's the final answer. That's final answer. Let's ask you to do one. So 2 over x plus 3. Be careful with this one though. 4 over x squared minus 9. And now, if you guys are smart, I'll teach you even better ways to do this question. Well, this is actually no, even faster way to do this question. So 2 over x plus 3 over 4 over x squared minus 9. 9 is an integer, 3 is an integer. You got it? Omar, you finished? Check with Aiden. Safa, you finished? Owen, you can check with your group leader. Astra can check with you that group. That group is pretty awesome. You check with him. Okay. Good.
I used to do by x. Yeah, that's okay. Yeah. Yes.
But can I check with the group, see how they're doing?
I did it because you're adding them together. I think it makes it. And then I rearranged it to make it 3x plus 2. And then what I did is When I say like really like you have to do it, I will turn by turn, so it's really three. So that's three from the first opportunity to run. And then this three is 2 times 2 is 14
All right, let's see this. If what are the common denominator between the top?
X.
X, so x over x. And what about here? X squared over x squared. I'm gonna show you a trick how to do it easier too, but this is it right now. So on the top it's gonna be x of 2 plus 3x. Am I okay? On the bottom it's gonna be x squared 4 minus 9x squared. Now that's gonna be 2 plus 3x over x, and this is gonna be, I'll just do keep change flip. Is that okay? And I'm gonna add x squared over. Now I don't like 4 minus 9x squared. Why is that? Well, it's also descending order, but it's also difference of square. Actually, can factor this because the other side is 2 plus 3x. So I can change this to 2 parentheses. What would it be? What is it? You can actually do it this way too. You can actually do it this way too. You don't have to take out a -1, but because in this case, there's choose in the front, I can choose to do that, but you can choose to do that in a second. So that's going to cancel out. This is going to cancel out. So it'll be x over 2 minus 3x. How many of you guys got this? Very good, very good, very good. Good job. Charlotte, where you mess up? Okay, you cannot take out -x if it's different. -1 you can. You can take out -1. So that's going to be -1 times 9x squared minus 4. So that's going to be 3x plus 2 and then 3x minus 2. Then your answer is not much different, right? Should be the same. Because 3x plus 2 and 3x plus 2 is going to cancel out regardless. Okay. All right, let's try again. Now, I want to tell you there's something different between two. A lot of you guys don't understand how to rewrite this. So let's just say 2x, say it's 5x to the -1 versus 5x to the -1. So remember I asked you first question. Now this one's a little bit more difficult. What will be the simplification of 5x to the -1? How do I rewrite them? Yes, Omar?
It's 5 over.
5 over x. Now what's the difference between the first one and the second one?
Distributes within in the parentheses.
So what would it be?
The yeah. No, oh, sorry, 1 over 5.
1 over 5x. The whole thing goes underneath. Right? The whole thing goes underneath. Besides, this is probably something you need to know for today because some homework is going to be like this. And you have to rewrite that and to do the different things. So I'm going to show you two things. One is this question. I'm going to show you a faster way to do these questions. Not everybody can do it, but I can show you how to do it. What's the least common denominator for the top and bottom? X squared. So now I'm going to show you a trick. If you can do it this way, you can do it also this way too. So let's talk about faster way. If you can figure out top and bottom is x squared over x squared, the GCF of top x and x squared is x squared. Now, for those of you guys are not good at math, don't try this. But if you try, you can experiment. The more experiment that you try, it's going to be figure out what happens. So if you distribute this way, what am I going to get? What am I going to get? The first one, x squared times 2x, 2 over x is going to be what? What? 2x, 2 over x times x squared is what? Just 2x, right? Plus 3x squared, right? And on the bottom is going to be 4 minus 9x squared. Do you see that? And what can you factor on the top? And what can you factor on the bottom? That's for me. This is also a very cool way to do a questions. Now, this for me is a faster way to do something, but I don't know. So I'm gonna give you a question a little bit out of your league, and let's see if you can handle it. Remember, you should always rewrite this. Okay, you should rewrite this. So this one's okay. This one's okay. It's not too bad. Don't think it's out of your league. I think everybody can get this one. And this what I put on my calculus test. It may be on your test. Okay, so this is what I put on. Can I rewrite all the things there? Can I rewrite it? So 5x to the negative 1, can I rewrite it? What can I rewrite as? 5x, good. So the first step, rewrite this. 2y to the negative 1. What is it? 2 over y, good. Now it becomes the same problem as before. 25 over x squared minus 4y squared. That's only thing difference between this question and the previous questions. That's only thing difference. Make sure you rewrite those, become its own thing. Now, some people think like this, right? This going all the way down here. No, that's not true. That's not true. Don't think like that, because that only the extra negative one, only extra negative one affecting, not affecting the whole thing. That doesn't cancel. That doesn't do anything crazy. Do you see what I'm trying to say? This is still the same problem as before. And this I put on my calculus test. Nobody knew what to do. Everybody flunked it. And that's why I want you to do. Before next year you get there, you're gonna be like, okay, I got this. Cake. Light work. That's what you guys called it. Multiply this divided by y over y, x over x. This is y squared over y squared, x squared over x squared. Do you guys do that? Now I did it a little longer way, but you guys can try to figure out if you can do the shorter way. Because I don't have time. And this will simplify here because that's a factor. This will simplify. This will simplify. So it'll be xy over 5y plus 2x. Good. Now this one's actually interesting. I want you to rewrite and make sure you rewrite it correctly. Check with each other before you move on. Two x to the negative 1 plus 2x to the negative 1 over x to the negative 1 plus 2x to the negative 2. At least make sure your first step is gonna right thing. So the first one, it should have been 2 over x. Did you do that?
Mhm.
Plus 1 over 2x. Did you do that? Okay, good. 1 over x plus 2 over x squared. Now, I'm pretty sure that you know how to combine fractions here, but this time I'm going to take a risk to do an easier path. What is the LCD between x2x, x, and x squared? What is it? 2x squared. Good. So I'm going to multiply that. I'm going to show you this interesting way. This one is going to give you what? What is it? 4x. No, 4x. Because the x squared cancels out with the x. Do you see that? What happened if you cancel out with this? No, x over 1, which is x, right? Does that make sense?
Mhm.
What's at the bottom? 2x, right? Plus what? 4, would you say? Is that okay?
Yeah.
And then this is going to be 5x over 2x plus 4. Done. Hopefully you learned something.
When we get into denominator, you teach me how to do it.
Yeah, just denominator tonight. You go to
No, I'll come in after school one day, but I cannot do domains for my life.
Okay.
Actually, I was everything giving like a note for my coach.
Yeah, what do you do?
I swim.
You swim? Oh,
Yeah.
you are same as her?
Yeah, and I'll swim for her.
Oh, okay. I'll use a pad so that way that.
Yeah. She's like 5, so she knows I wasn't skipping.
I'm pretty sure she knows you. What's up?
Sorry, my background might be-
No, I saw your mom emailed me. That's fine.
Oh, there.
But make sure you do today's homework, yeah?
Yes, I know.
Okay.
We got
Alright.
a bunch.
No, I saw you.
And a bunch, and then a bunch. I
Alright,
was
good.
going to do all 44, but eventually my brain started running at the speed of
No, it's okay. I don't
running faster.
I don't want you to punish yourself. I want you to do it right the first time.
I did most of them, but
Okay, what's up, Safa?
So I'm tutoring her after school today, and I'm gonna start her with efficient today.
And you gotta teach how to use it. So come at lunch if you have problem use it. Try to use it yourself and try to use it yourself. Try to see how it works. And I'll show you my son's version so you can see how it works. You can actually screw it up if you want. That doesn't matter. So you can actually try different things on it, and that way you know how exactly how it functions.
Yeah, I'll just come by during lunch.
Yeah, it's fun. What's her name?
Zimmerman.
How to spell it?
Zimm.
Z-I.
And
Holy shit, I spelled totally wrong. I spelled with C-I.
then ERMAN.
What's your name?
Astrid. AS.
It's Miss, right?
Excuse me?
It's a girl, right?
Yeah, Miss Zimmerman.
Astrid
Mhm.
was after school tutoring. Last Monday? It's Monday, right?
I think it's Tuesday. It was Tuesday, yeah, because Monday I went there. Thank you, Mr. D. Question about the problem for this one.
Yeah.
Okay, wait. Even like somewhere, but when you multiply it by a squared, it just became 2x. And I was wondering how.
Where? I don't see.
Maybe it was the one before this. Yes. It was.
This is required reading.
Yeah.
Sounds pretty boring.
Right here. Like when you multiply that by x squared, how did that become 2x? Like the 2.
Because x squared times 2 over x. If you write it next to each other, x and x cancel out. So left with the x times 2 is 2x.
Okay. So when you're multiplying,
Does
would
that-
it be like you're multiplying by x squared over 1?
So if you have x squared times 2 over x, right? This
Yeah.
cancel out. So that would 2x.
Okay. Missing.
Hi.
Hey, Monsieur.
Did the sim call you?
No.
He replied to you now.
He
He
did?
texted you back. He said that he's your friend. And he said I called him. I was like,
He did not text me that.
huh?
He did not text
He
me.
left you on red?
He left me on. Yeah, he didn't even open. Just
What a
not
bastard.
I'll tell him when I get home. Half.
I was sick.
One minute remaining in the hill.
Can I use the bathroom?
Stay away from me.
I'm gonna get closer to you.
No. I'll karate chop you.
Splendid.
Can I get half?
Yeah. Where are you going?
Environment?
Davis?
No, Miss Smith.
Oh, good. She always give me a hard time. You know, I write a pass once. I just write a name here, and Mr. Davis, sent a note back the following day saying, "This is how you write a pass." I'm like, "What a jackass!" Where are you going?
Miss Smith.
Time is.
You definitely $19.
I don't know what's today.
No,
31st?
31.
Oh, Nathan. What?
Thank you.
Right. Don't even. I was so mad at my parents. It was like annoying. No, Raj literally offered me a ride there and a ride back, and my parents just didn't.
What happened to your group? They all died?
Nathan, you could have slept over. They got scared of life. You could have slept over.
They're
Too.
scared of
I
the
wanted to. My mom, I'm not letting you sleep. And I'm like, all right, let me go to hang out. And then I'm like, I can literally get a ride there and die. And she's like, no, I don't want you to.
Ask me, who's your friend in this two? What's the name? What kind of group are you?
I know what you look like. One has glasses.
I know what you look like, and I know what's your name, and I have like freaking 50 student to face. You're gonna fail if you don't know her name.
I think this one's Melissa.
Yeah.
Vanessa, yeah. I don't know. I know what she looks like though.
What does she look like?
She has like braids, and then like-
Oh.
Yeah.
I'm being honest.
John's being racist again?
What? No? Yes, he is. I literally heard him say it. I literally heard him over here.
So
How's that being racist? How? I can hear you, though. Okay, but how is that being racist?
Sean, I'm gonna cancel you one thing.
You're gonna cancel me?
Yeah.
You should hear Kevin.
Kevin haven't said anything crazy.
Oh, you sure about that? He said you haven't said anything crazy. Yeah, I haven't. You want to see the videos? We actually start
We start introduction to calculus. Not even calculus. All right, yeah, if you make this far, yeah, that's good. Is anybody, Okay, well, we'll see what happens.
Damn, there's like nobody here.
Everybody's scared Laxmi. What did you do, Laxmi?
I didn't do anything.
You trying to convince them to become vegan?
You know we have a meeting Friday. Mr. Yang.
Do they have vegan dish? Like actual vegan dish?
No, we got Oreos. Mr. Yang, do you know how many people are in your live? Be quiet, We got 51 on Instagram.
See, the problem
Yeah.
the problem is if you say you're vegan, then maybe more people will join.
No, but we got real vegans in the club.
Except the president is not real.
Why do you make a club if you're not vegan?
Because I love vegans.
No one likes vegans, bro.
The truth is, she's trying to do it for college, and that's where the truth is. And she cannot come up with a club name, and she comes and says, "Oh, now I'm just gonna be a vegan friendly."
How
Wow.
many people do you expect to show up on Friday? Probably like 100.
If you say there's free food, everybody will show up.
Yeah.
It doesn't matter vegan or not. Oreo's not food.
Vegan people can't have Oreo.
Yeah, they are. They're vegan.
Vegan.
No, the actual Oreos are vegan.
Wait, really?
Yeah, they just use like a lot of chemicals.
So they just poison you a different way. Anyway, all right. So, yes, we are taking notes.
Your name?
You kind
All right, shut the hell up. Thank you. All right, so limits. That's the first thing we're gonna deal with. In math, we're gonna see this notation, LIM. Please don't call it lim. Just piss me off if you do that. Just call it limits. Okay. Why do we need to use limits? So, what is limits? Does anybody know what's limit? Did Mr. Oli or Mr. Cooper explain to you what a limit is? Yes.
Is it basically like where that like there's like a imaginary line or like kind of like an asymptote like where it can't reach?
You could apply limits there, yeah, but yeah, possibly. Okay. You can reach. Okay. All right. Anybody else know anything about limits? All right. Nobody? Not even from Cooper's class? I think Cooper's class probably talked about limit. Anybody from Cooper's class? Did she talk about limits?
I don't really remember. I'm assuming it's kind of like a restriction.
Okay. Did Oli talk about limits?
Yeah.
It's okay. That,
Yeah.
all right. So, let's start with the limits. Let's start understanding. Why do we use limits, right? So, we're gonna start limits numerically. Okay, numerically, it's gonna be that's the things that you gotta be able to see. So we're gonna start with the equation. We're gonna start with this equation says x over square root of x plus 1 minus 1. And not owning anything, I'm not gonna write a limit here. and so x approach 0. Now this part is kind of interesting. Now, what does that mean when limit x approach 0?
X can be 0.
Huh?
X can be 0.
Why not?
Then you have x over 0.
Well, not x over 0.
0 over 0.
0 over 0. Good. So you have something like 0 over 0. So Nathan kind of anticipate what happened, which is good. A lot of you guys should anticipate what is going on next and try to guess why is that a problem. So you're going to get 0 over 0. Now, you never heard of a 0 over 0 in the past. You always have heard what number over 0 is what? Undefined. Good. So you know some basic math. Number over 0, undefined. 0 over number is what? 0. So, okay, so that's basic thing, understanding. So you cannot have a number over 0 because math doesn't work that way. It's just undefined. But 0 over number, it's perfectly fine. But we never ever talk about 0 over 0. Have I ever we talk about 0 over 0? Okay, so that's something. So what we're going to do is we're going to actually using a numerical approach. A numerical approach is to be able to plug in calculator. So, but since you guys don't know how to use calculator yet, and I'm not teaching you how to use calculator until end of the third quarter, so I'm going to teach you how to use Desmos. Okay, so you're going to go to Desmos, and this your best friend here, and remember it's x divide, and it will straight go to the denominator of x plus 1, and you need to download that app. Besides, subscribe to Mr. Ye, and then so you're gonna have this graph. Okay, so go on download the Desmos apps if you can and type in this function. And today you're gonna plug in some numbers for me, and you're gonna see what number they are approaching. So you're gonna try to do limits numerically. So what we're gonna do is click on this. Do you see that wheel on top of the equation? There's a small wheel, looks like a wheel, a flower. Do you see that? Yeah. Okay, click on it and build a table. You see the table there? Click on the table. Now, we don't care about -2. Now, can you tell me why -2 is undefined, however? Can you tell me why -2 is undefined? You cannot have negative number inside the square root. Perfect. Because that's called domain. So if you want to know the domain of this function, if I say, hey, can you find the domain of this function? You're going to say x has to be greater than -1.
Would it be greater than -2?
No, -1.
Oh, yeah.
Because if it's a -1.01, then it's undefined inside. And it's not -1 either because -1's okay. So it has to be greater or equal to -1. Okay, so now what we're gonna do is approaching something. So anybody have siblings at home? Anybody have younger siblings? Okay, good. Okay, Shank's got a few. How old are they?
8, 10, and 12.
Okay. I don't know, like I don't know when you're little, right? I don't know. When we grow up, we don't have like when I grew up, I don't have electronic. We just always have a fight with each other. And the way is how to start a fight is you put a finger in there in front of the face, right? And it's like, I'm not touching you, I'm not touching you, I'm not touching you. Have you did that before?
Yes.
You did that?
Mm-hmm.
Okay. And I'm not touching you until you get so close to them and they get really pissed off and they like slap your hand and then you slap back and you start going to a brawl between two kids, right? That is the idea of this situation. The ideal situation is you want to get infinite close to them until but you're not touching them until they get pissed off. But if they take a swing at you, you're allowed to swing back harder, right? So that's the idea that you want to do. You want to get something so close, but you want to approach it in different things. I don't know. Do you guys ever watch Dragon Ball? No, man, this generation sucks. Okay. Just as I said, today, if I have a situations here, so I think Omar, come up here. Okay, so it's not, yeah, okay. So let's just say we have a small black hole right between this tile. You guys cannot see right between the edge of this tile, right? And that's where the edge, the tile cross each other. Simon, what the hell? Okay. So what we're gonna do is we're gonna take our phone and we're gonna say, hey, I'm gonna using a GPS. I'm gonna find out what a black hole is, right? So, but is the reason if I take a GPS and stand on top of a black hole?
No.
No, why not?
Because you get hooked in.
Yeah, how many ways to die in black hole?
What?
No. There was like 16 different ways you can die in a black hole. You either become atom because of gravity just kind of pull you apart, or you become spaghetti. It's called spaghettification. Have you heard that before?
No.
No? It's called spaghettification. You just become spaghetti just a long stretch because the gravity can pull you so fast you become a spaghetti. That's what happens. You want to die that way?
I mean, if I were to go, I think that's the best way to go.
I have to say, that's my too. I don't want to get hit by a truck, or I don't want to have like a heart attack, and I don't want to drown to death. But I think black hole, yeah, that's the way I want to die. Okay, so if there's a black hole here, and we want to find out this location, we cannot take a GPS and tag that says, okay, well, it's yay, I'm on top of a black hole. The GPS show me I'm at coordinate 2, 3. But before I do that, I'm gonna die. So before that is what we're gonna do is we can approach both directions. And each person is gonna kind of report a number on the way there. Is that okay? So what we're gonna do is we're gonna do here, and we're gonna say, hey, let's approach this black hole. And you Omar's gonna take 1 step forward, and I'm gonna take 1 step forward, right? And then we're gonna record a GPS. We say, oh yeah, that's like almost like, let's say in the x-axis, that's almost like 1.5, and we're gonna take another step forward, and we're gonna do this, and then we're gonna take another step forward. I really don't want to kiss Omar because we have my height. So, and we say, okay, here I'm at like 1.9, and he's like 2.1. So we can take another half step further, and we can take another half step further, so that then we get very close, become very uncomfortable. So basically, you're gonna get very close to it and see, what's the closest you can get, but not get on top of the black hole. What's the closest we can be, but not kissing each other? Pretty much, right? Oh, I get 5. So thank you, Omar.
Black hole means fun.
Huh?
Black hole means fun.
Okay, so what happened is here I want to do that. So what we're gonna do is we're gonna approach 0 that way. So what we're gonna do is we know approach 0, it says undefined over there. Do you see that it says undefined? Yeah. Okay, so what we're gonna do is we're gonna approach 0 from the left side. So we're gonna start with -1, and on the other side we're gonna start with 1. Is that okay? So you see that 2.414? And what we're gonna do is we're gonna approach this, and we're gonna press enter. We're gonna say, hey, let's do approach another number, say it's 0.5. So -0.5. Here we're gonna press enter. We're gonna say that says say it's 0.5 here. And this is a 1. Is that okay? So you see that value is one size 1.707. And then you say, okay, well, we want another value that says -0.1. Is that okay? And this side, I'm gonna press enter, and I'm gonna say positive 0.1, and this is 0.5. Is that okay? Now we say 0.1 is super close, -0.1 is super close. Let's say, hey, that's approach negative 0.01. Sorry, not supposed to have equal sign. It's supposed to have a negative sign though. Negative 0.01. And if you do here, you should try it. 0.01. And you see that value is getting closer to what? Yeah, 1 is 1.99. You see the output is 1.99. And we can do one more, just kind of show you what happened, which is negative 0.001. Oops. Did I type it or something wrong? Negative 0.001. And that's going to give you a value. And then I'm going to press enter here. So 0.001. And you see that it's 1.999 on the other side and 2.000 on the other side. But we know that we can estimate that small infinitesimally small black hole is going to be probably more likely located at 2. Is that okay? And that's called numerical approach. So today's homework, you might have to use a Desmos calculator and plug in this thing until you see what it reached 2. But you can see it from the graph. They obviously go into 2. But let's show you on a graph. So let's get rid of this. And let's show you on the graphs. So that this, right? Do you see anything abnormal? Do you see that? That's the black hole we were talking about. That's a small, infinitesimally small black hole that we're talking about. And that's the things that you got to think about. Hey, how do I approach using limit? Limit is this. You're going to approach a value slowly on both sides. And almost assume that you can get so close that assume that you can be on top of it. And that's the value you're going to get. That's the output. So assume that you can get there. But you're not going to assume you're going to get it slowly approaching. Like, I'm not touching you, I'm not touching you, I'm not touching you, or I'm not kissing Omar, I'm not kissing Omar, I'm not kissing Omar. It's same idea. It's what you're going to do is going to go so close to it, but not touching it. Okay. Does that make sense? Okay. All right. So now you're going to get to understanding. Now, understanding, I'm going to give you a test. This one is actually interesting. This one is, nobody know the graph of this one look like, but I want you don't use graphing calculator. I want you to anticipate what this graph look like. So we know, sorry, let me finish this. Numerical approach and use that table. So in today, you have to figure out, okay, what a table look like. And you're going to plug in the value until you see the value going. But why it's not working? Okay. Why it's not working? Okay, it's working now. What happened to my old notes? Okay. So we know that we built this table that's when limit x approaches the 0 of x over square root x plus 1 minus 1 is equal to 2. It's called numerical approach using that table. I'm not going to write down that table again, but you guys saw the table. It's from here. Oh, it's gone. But anyway, it's equal to 2. Is that okay? Now, I'm going to talk about that's numerical approach. That's a stupid way to do it. That's fine. We're going to teach you how to do it smart way tomorrow. But today, just understanding when this limit does not exist. Okay. Limit does not exist at 3 situations. 1. Limits x approach to a from the left of f of x does not equal limit x approach a from the right of f of x. That means I reach, so the last limit exists because they both come into 2. Like from the left side, it come into 2. From the right side, it come into 2. So therefore, limit does exist. But in the situation if we're approaching the left side does not equal to the right side. So when this does not equal to each other, limit does not exist. So if I come in from the left side, I says, hey, my GPS says 2. And Omar come the other side, my GPS says -3. Then you say, wait, that doesn't make sense. That doesn't add up, right? So that means that limit does not exist. Is that okay? Am I going too fast? No, okay. The second thing limit does not exist is something called unbounded behavior. Unbounded behavior, more likely like some type of asymptote. Some type of asymptote. Now this one is debatable. Sometimes they say that does not exist. Sometimes it says things. So, but I would say f of x equal to 1 over x squared. When x approaches 0, what will happen? It's undefined. Now, difference between undefined and the last case is 0 over 0. We're going to talk about what a 0 over 0 means. It's not undefined when you have 0 over 0. Actually, I'm going to tell you today. If you have a 0 over 0, that means indeterminate. Okay, indeterminate is you cannot determine yet. In this case, we got 2 after we do a numerical approach. After we approach slowly, we got 2. But at this case, if we approach 0 on the unbounded behavior, 1 over x squared, that's going to be an asymptote. And the asymptote is going to look like this. It's like volcano. Okay, so this is a 1 over x squared. Now, at x equal to 0, limit does not exist. Now, we're going to talk about this. This kind of ambiguity between textbook. Even this textbook had 2 parts, and they represent 2 different things. So in this case, we're going to call it unbound behavior. Unbound behavior limit does not exist. Even they both going up, right? Keep on going up. They reaching the infinity at the same time. So still, that's going to be one of the things that it's going to be the limit does not exist. One last thing, limit does not exist. It's called oscillation. Oscillation is a kind of very cool things. So oscillation is going to look like something like so it's going to be look at something like this, and this graph is going to be like this in particular. And like this. And this oscillation. But I'm going to tell you what the oscillation look like. We're going to give you an example of each. So let's start with the first example. When is this? Okay. And that's interesting because I'm going to show you something today that you've never seen this graph before. Don't use a calculator and try to imagine what this graph will be. So this graph, we're going to use this example, first example here. We're going to say, okay, well, what if our function looks like this? Absolute value x over x. Now, you guys cannot use calculator. I want you guys to think about what would this graph look like? What would this graph look like? Anybody have an idea? Raise your hand. I know Nathan can see that. I want to like more people besides the one. So I'm gonna call Nathan at the end, but I'm gonna call somebody else first. Does anybody have balls to try it? Kevin's pretty big, but he had no balls.
Wait, can you add that's the question making that?
What would be absolute value x over x graph look like?
Define when it's positive on 1 and then when it's less than 0. When the x is less than 0, it would be like negative 1 on line. So 2 different lines.
Kevin?
So you said what would the absolute value look like, which means like absolute value is like this, right? It's like a little curve, like this way or this. Are you asking what the graph would look like?
Yeah.
Absolute value.
The absolute value, yeah. Do you know what absolute value graph look like?
Is it like curved to the side?
No. Simon?
I don't know. I think like my best guess is maybe either like the. I'll say just like absolute. Like, if it's like transformation.
Same.
I feel like it gets stretched.
Yeah, seems reasonable if the x is 2. The absolute value 2 is 22, but let's use 1 is linear to multiply by negative 2. So that'd be negative. X is equal to you have basically if your x is less than 0, it would always be equal to negative 1. If it was greater than 0.
Okay, Nathan, what do you think?
Like any negative value is going to be like a straight line, so you always be negative 1. And once you approach where x equals 0, it's going to be a hole because you're going to have like 0 over 0, and it's going to go back up. And any positive value you put in is going to be.
Okay, so we have two people think like that. Okay, Lyndon and Nathan. Anybody else wanted to add? I'm not saying right or wrong. I'm just saying, hey. Relax me, what do you think?
Oh. I don't know. I thought the same thing as Landon, like I wrote that down. But I don't know what else.
What I like is what Lyndon's thinking about. And Nathan is just more intuitive. Lyndon's thinking about what if I plug in numbers, right? If I plug in 1, then it's going to be 1 over 1 is 1. If I plug in 2, then it's going to be 2 over 2 is 1. If I plug in 3, it's going to be 3 over 3 is 1. Now, if I plug in negative number, what will happen? If I plug in negative 1, so he's thinking about numerical approach, and that's what you're supposed to start thinking. What is negative 1 over 1? Well, absolute value of negative 1 is 1, but bottom is negative 1, so therefore it's negative 1. Does that make sense? So then you start plugging its value. Now, this what interesting thing is, a lot of people says, you know, what a graph look like. Absolute value graph look like this. Now, if I divide it by x, which is you guys never saying, it looks like this. Now, this is exactly the first case I was talking about. Limit does not exist. Why? A graph look like this. On the left side, it's going to be from here, go into here. And from here, go into here. So if I approach left side, let's say Omar's approaching left side, right? And if I approach him from here, go all over here, Omar says, oh, my GPS shows negative 1. And me approaching here, my GPS says, no, I'm positive 1. So therefore, it's inconclusive. We don't know this small black hole was negative 1 or positive 1. So therefore, we say limit does not exist. Could be anywhere along this line, but I don't know what is it. Okay, yeah.
So does a limit have to be a continuous function?
No, I don't think you know what a continuous mean yet. So we're gonna talk about continuous in a second because we're gonna say what's the definition of continuity. Okay. But I think you are thinking about different things, I believe. Okay, so that's okay. So let's start by recognize how this graph is. Now, I want to teach you something else besides this. It's called at this example, using this example, teach you something called definition of absolute value. Definition of absolute value is actually gonna help you solve a lot of the problem. Absolute value. So if I have definition of absolute value, what's that? Well, first of all, let's graph the definition of absolute value. Let's graph the absolute value function. Absolute value function look like this, and the red part is gonna look like this. So this is absolute value function. So first of all, I will write down absolute value function f of x is equal to absolute value x, right? And we're gonna go back to talk about our questions. Now, you can write something called piecewise function. Most of you guys don't know what piecewise function is. Basically, I'm gonna write this in two pieces, and with each piece with different domain. So on the right piece, we're gonna call this side is x. Is that okay? So that'd be x when x greater than 0. Greater than or equal to 0. Now on this side, it's gonna be negative of absolute value. So it'll be a negative x. So it'll be negative x when x is less than 0. So that becomes a piecewise function. I can write this function in two pieces, and this two pieces is gonna apply to whatever question before. So does that make sense? It's minus a parenthesis here. Let me help you. Is minus parenthesis of x, because on other cases it's going to be the same thing. So I'll give you another case where absolute value, definition of absolute value come in place. So let's just say if I have f of x equal to x minus 2, what does the graph do? Shift to the right. 2 places to the right. So you should get this, right? And again, you got a right part function. It's going to be 2. That's going to be x minus 2. Is that okay?
Yep.
And what's the left part of the function? What will be the left part of the function? Almost. Can you make up your mind? What is it? Negative what?
Plus 2.
Okay, that's good. But I'd rather you write like this, so that's less confusion. So negative parenthesis x minus 2. So this you can rewrite as this. Remember, this is going to be very helpful later. So it'll be x minus 2 when x is greater or equal to, greater or equal to 2. Is that okay? And x minus 2 minus when x less than 2. That will be two functions. Are we okay here? So let's go back and rewrite that. So let's go back to the question. So back to the question. F of x equal to absolute value of x over x. Then I can write in two functions, can I? If I write in two functions, it's going to be a piecewise function. And here, when it's greater than 0, this absolute value x is going to change into y. Just positive x over x. Does that make sense? When x is less than 0, it's going to be negative x over x, because it's going to be negative version of absolute value. Now I can obviously simplify this. I can say, well, this is 1 when x greater than 0, and this is negative 1 when x is less than 0. Now don't pay attention that they're greater or equal to in this case, because it doesn't really matter. It just actually they both are not, because you cannot equal to 0 over 0. So does that make sense? So therefore you got a function look like, on this side is going to give you a positive 1 going this way, and this one's going this way. Is that okay? And that show you limits x approach to 0 from the left side of absolute value x over x is equal to what? If I'm approaching from the left side, what is that equal to? Negative 1, good. Because according to this graph, if I look at this graph, it's going to be negative 1. If limits x approach 0 from the positive side of absolute value x over x is equal to what? 1. So therefore, because this reason, limit x approach to 0 of x over x is equal to does not exist because 1 is approaching -1, 1 is approaching +1. Limit does not exist this way. Yes.
So why is that? But like, wouldn't like it be a point where -1 and 1?
No, it's gonna be like this. The only way it's gonna exist is gonna be like this.
Also has to.
They have to reach a common point. If they reach two different points, limit x approach left is reach -1, and this reach +1, that does not exist. Because these two are not equal to each other. See, you are fall into this. Wait, where did I write it? Right here. Because limit does not equal from the left does not equal to the right. That means limit does not exist.
Or like transformations look
What?
how would it look like transformation?
About what?
Like for
Absolute value x looks like this. Now, if we have absolute value x minus 2, it's going to move right too.
no, like x absolute value x.
Yeah, then that's going to look like this. On the left, it's going to be 1. On the right, it's going to be -1.
Like, will we ever have to deal with like transformation?
Yeah, possibly. We don't know yet.
So how would that
You're gonna see it in the later when maybe homework and stuff like that. Okay. Now we're gonna talk about the example of. Now this one we already talked for the second example. It's like 1 over x squared. That is gonna be limit does not exist. But again, this is there's a lot of ambiguous situation. I think that's how to spell ambiguous. I don't know. Because sometimes they can say that's positive infinity, or sometimes they can say limit does not exist, but it's never two answer in one choice. Either the limit does not exist, or they're gonna be positive infinity. But it's not gonna be both exist in one choice. So for example, if I were to ask limit x approach to 0 on 1 over x, so let's say limit x approach to 0 on 1 over x squared, usually it's gonna be does not exist. But sometimes people say that's positive infinity because going from the left side is infinity, going the right side is infinity, but not both answers are showing at the same time. Usually it's only one of those answers. It's gonna be infinity. It's one of the answer choice, but doesn't have it does not exist as answer choice. If they both show up as answer choice, that's a faulty problem. That will be the problem we can go to College Board says that doesn't make sense. They got two cases. So usually you're gonna put does not exist. Sometimes you want to put it positive infinity. If a positive infinity is your choice. So those are the things that I will say. Now, lastly, oscillation. Those of you guys have Asian parents, you know. Asian parents are good at yelling, right? They're good at yelling at you. He already says, yeah. Does your parents yell? Yeah. Kevin, does your parents yell? Nah, you? Are you the only kids?
No, I have a sister. My parents don't look. They're kind of lenient for Asian people.
Okay. All right. So there's a sign of 1 over x, this one. Now I'm going to build a table here. This is actually interesting. So I'm going to build a table of x and y here. And y is equal to sine of 1 over x. Now, sorry, I'm going to build the other table. I'm going to build the other way. It's okay. I'm going to start with that. So I'm going to plug in some type of value. Now, this is interesting. I'm going to choose the value I'm going to plug in. So 2 over pi, I'm going to choose that. Can you tell me what is sine of 1 over 2 over pi?
Oh, it's 0. We know 1.
1 is good. Okay. So remember, we want to approach 0, right? So what we're going to do is the second value I'm going to plug in is going to be 2 over 3 pi. Okay. So I'm gonna plug in sine of 1 over 2 over 3 pi. No. I want to show you sine of 1 over 2 over 3 pi. Good job. That's means the sine of 3 pi over 2. That means -1. Does that make sense? Because it keep change flip, right?
Oh,
Okay, so the next one, 2 over 5 pi. Omar, what do you think?
I did you one.
That's 1. Okay. 2 over 7 pi. Sophia? -1's good. -1's good. I'm gonna keep on going. 2 over 9 pi. Hopefully you see the pattern. Sasha? 1, good. You see, she's like, I figured out a pattern. It was 1, -1, 1, -1. And now are you gonna do one more? 2 over 11 pi. That's gonna be -1. Is that okay? Now, what happened to this x value? Do you see this x value? The x is going toward what? If you have 2 on the top, and the bottom number keep on increasing, like 2 over 3, 2 over 4, 2 over 5, 2 over 6, 2 over 7, 2 over 8, what's a number going to what? It's going to a what? It's going to a what? 0. Thank you. You gotta be very affirmative because the number gets larger, right? 2 over 3, 2 over 4, 2 over 5, 2 over 6, 2 over 1,000, 2 over 2,000, 2 over 3,000, 2 over 5,000, 2 over 100,000. The decimal places keep on increasing, and that becomes going to a 0. Is that okay? And if that's going to a 0, guess what? The value is oscillating between 1 and -1, 1 and -1, 1 and -1, 1 and -1. Now, do you guys want to see this graph? It's freaking cool. I'm going to show you that. Look at this graph. Sine of 1 over x. It looks like this. And not only looks like this, it's very interesting. And I give it a knowledge to people is like this. I remember my mom, right? Like I have PTSD from my mom. She beat the shit out of me all the time when I was little. Like I'm serious. Like we're talking about heavy beating, and that's very normal. Like in Asian family, like at least my generation when we grew up, it's pretty normal. Your parents, some of your parents can probably tell you that. She will like when I look at her, right? She will yelling at me, and I'll look at her, right? She's like, "Why you stare at me when I'm yelling at you?" So she slapped across the face like this, right? And then when you look away because she slapped it, you just kind of turn your head away. Just don't stare at her, right? So and she'll be start yelling again. And she's like, "I'm talking to you. Why you not looking at me?" So when you look at her again, or when you not look, so she slapped back, and she give you, and you look at her, and she's like, "Why you stare at me?" And you slap again. So it's like there's no win situations, right? Now let's imagine that she has a superpower, right? She has superpower. She can increase her frequency, going left, forehand, backhand, forehand, backhand, forehand, backhand, forehand, backhand. But she's doing so fast that she's doing to a faster speed that you cannot see its speed of light. Okay, forehand, backhand, forehand, backhand, forehand, backhand. I say snap right here. I says, okay, what's the last slap that she gave it to you? A backhand or the forehand? And you'd be like, I don't know. Because it's so fast. Does that make sense? So look at this. Look at this graph. It's oscillating from -1, +1, -1, +1. And just keep on going. Now look at the graph, what happened in the middle when it reached zeros.
that's how fast.
So look at it. Forehand, backhand, forehand, backhand. And just keep on going. And so freaking fast that you cannot tell if he give you a forehand or backhand. And that's what happened in the middle. So limit does not exist because you don't know whether they are 1 or -1 or even 0. They don't even know. Nobody know because the hand gets faster and faster and faster and faster when they go into a 0. And there's no freaking way you'll know because this graph is not only like that. It's not able to tell. It's basically all the graphs crumbling together. It's going to be oscillating so fast, and that's why limit does not exist, because when limit x approaches 0, we don't know are they +1 or are they -1. And this actually does not exist. So this does not exist because the graph is like something like that, right? So it was like this, and like this, something like that. I don't know what happened when it goes 0. So that's the first part of understanding. Yes.
So when you say oscillating, like with the exact definition, like the value is just like it's like negative. So for example, 1 and -1.
Yeah, look at this. Look at this value is getting smaller, right? As I'm going close to 0. That is going to be like this.
It's just like the frequency of it, like it's so fast you can't tell.
Yeah, it's so fast that you cannot tell. You got it?
It's just so fast, therefore it doesn't exist.
Yeah, because you cannot tell whether it's forehand or backhand. If I can tell you that the limit has to be one number, right? You cannot tell me whether they are -1 or +1. Just like the other case. The other case went to -1. This one is went to +1. This one does not exist. Is that okay?
So like if you had like the window, wouldn't you be able to tell whether
You can. Because you can plug in 0 because you try to reach, you do it numerically, but we just do it to 2 over pi. This is 2 over 3. This is about 2 over 10 because 3 pi is about 2 over 10. This is about 5 pi. 5 pi is about 15, right? 2 over 15. 2 over 21. 2 over 27. 2 over 33. The number, the numerator stay in the same number. The bottom keep on increasing. I'm going towards 0. As I'm going towards 0, I only see +1, -1, +1, -1. But if I go into or even see this number is 2 over 13 pi, 2 over 15 pi, it's just gonna get smaller. And once it gets smaller, I still don't know are they positive or negative.
So yeah, we have like a
Not today. Today we're just gonna ask you to plug in limit numerically.
There's like no definite.
Exactly. That's the what a sum of. That's easiest summary that you can think of. You play guitar?
I do, yeah.
Nice. That's easy to get a girlfriend if you play guitar.
I'm walking proof that's not true.
You're walking through.
beat like as a child, and its mom grabbed it and you stick it started like hitting it.
Yeah, it's pretty normal.
That's
We're about, how old is he?
he's 60 now.
Oh, he's 60? Oh, he's older than me.
My dad's a grandpa.
Huh?
Or no, not a grandpa. But he's like an age of a grandpa.
Okay.